So this is the assembly of the SpikenzieLabs product called the Useless Machine with Counter. It's their model SPL-R023005. It comes for about $40. I think it'd be about half of that without the counter option. The product arrives in a padded envelope in 2 plastic bags, one with all the case parts and one with all the electronic parts. As with so many of these kits now, it doesn't come with any printed instructions, and one has to go directly to the website to get the instructions.
The parts bag is in 2 sections. The one section has most of the mechanical and electromechanical parts, such as the battery holder, some spacers, screws and washers, rubber feet, and the motor and gearbox assembly. The other bag has the parts for the Useless Machine's electrical circuit board, which is really just a couple resistors, some terminals, a snap switch, a toggle switch, and an LED. Not much to it. The motor assembly consists of the motor unit itself, which is a small DC motor coupled already with a gearbox with a right angle output shaft, 2 plexiglass frame members, a couple of long screws, and associated nuts.
There, finally. The tabs go through the holes in the board.
The machine's electrical board mounts to the motor frame assembly using 2 short bolts with nuts. The nuts are held in place in small notches in the plexiglass frames, and then the bolts go through the circuit board into a slot in the frames and then go into those nuts, and the whole thing holds together rather firmly. The next step is to get the gearbox output shaft aligned so that it's vertical as shown in this photo. It's most likely not that way from the factory, so the motor leads are temporarily connected to the battery clip, and you just touch the wires a little bit at a time until you inch the output shaft of the gearbox into the desired position. At that point, a large washer is placed over the output shaft to separate the machine's arm from the motor frame, and then the arm is slipped over the output shaft, and then finally a small screw and a washer are used to affix the arm to the motor shaft. In this final picture you can see how the small limit switch on the electrical board has its metal arm engaging the machine's arm. The shape of the arm acts like a cam, which actuates the limit switch at the desired times. The base panel of the plexiglass case has 2 slots in it into which tabs on the bottom of the motor frame will fit, and then the motor frame is affixed with a single bolt and nut to the case base panel in the same manner that the bolts and nuts were used to affix the electrical circuit board to the motor frame in previous steps. The kit comes with 4 silicone rubber feet with adhesive backing, and these are peeled off and stuck to the bottom of the case's base panel near the corners. The battery holder that was previously used to step the motor assembly's output shaft into the correct position prior to mounting the machine arm is now prepared with a piece of Velcro stuck on the bottom of the battery holder, and then that assembly is in turn placed onto the case's base panel next to the arm.
Alright, this is a preliminary test here. I'm supposed to flip the switch away from the arm, install the last battery in the holder, and the arm move down like it's supposed to. If I switch to the arm, it switches itself off and the arm returns to normal. If I turn the switch on, it immediately turns itself off. So that's good. And there seems to be an LED illumination involved too, green and red during the transition.
The useless machine can be obtained by itself or in a version with an included counter, or you can buy the basic machine and the basic counter and put them together. So 3 different ways of doing it. Mine did come with the counter, and the counter worked, but it didn't seem to be working quite correctly. And I'd been messing around with some jumpers on it that weren't supported by the manual, and I thought I might have caused it by doing something that affected the firmware. So I went and ordered a replacement counter kit from SpikenzieLabs, and I think they're only about $10. And I included in my comments that I might have damaged the first one, but I wasn't sure and hadn't been able to reach SpikenzieLabs tech support, so they refunded the cost of the replacement counter, but did not refund the postage, so they sort of met me halfway on that. So some of the narration in what follows might be a little confusing because part of it is of the original counter and part of it is of the replacement counter, but for the purposes of this YouTube video, just treat it like it's the one and only counter.
Alright, so I've got the original counter here that somehow I jazzed up. So I've obtained another kit from SpikenzieLabs, which I'm going to build and replace the original with it. The other thing I've done here is I've obtained, I also did this for my SpikenzieLabs calculator kit. I bought these from DigiKey. It's a red Lexan lens for a 2.5-inch wide bezel. Here's all the information, and you end up with a packet of red lenses, which I think are big enough for this window and then some. So my goal is to cut down a piece of it that's just exactly the right size for the LEDs, and then super glue it on like I did with the calculator. It'll make it look a lot better.
The counter has a small double-sided circuit board, several types of pin headers, a battery connector cable, 4 red LED modules, some resistors, another snap type limit switch, capacitors, and bits and pieces of hardware, and then the PIC microcontroller chip. The PIC microcontroller is shown here. It's apparently hackable if you have the right equipment to work with the PIC type processors. It's not directly supported by the instructions for the counter, but apparently if you already know how to work with these things, it is hackable. You can get into it and change the firmware and make it behave a little differently.
So the first step in assembling the counter is to put on the 3 resistors. They're all the same value. They're all 10K. So there are the resistors. Then there are the 2 capacitors. And there are the capacitors. Now the next step, it can be a little tricky because there's these male pin headers. This one for a jumper and the curved one for the battery. And they go on the back of the board, not the side that the other parts have been going on. And they do mark them accordingly. You see there's no marks here for anything to go in that position, but if you flip it over, it's marked with the normally closed, normally open jumper header. And then over here is the similarly marked one for the power connector. Okay, there's the power connector and the pin header for the jumper. And likewise, the limit switch or micro switch goes in this position on the same side of the board as the jumpers. And it goes in with the hinge side in this orientation. So there's the micro switch soldered to the board. Slightly cheesy thing, but it is effective and inexpensive. We're trying to make sockets for these LEDs, which have narrow pins on them, which will fit into little IC sockets. But instead of IC sockets, they're having the kit builder chop these pin headers, or I'm sorry, these socket headers, which they call Swiss pins. Everywhere I've gone, I've heard these referred to as screw machine sockets, but I guess some places they call them Swiss pins. Anyway, it's basically the same thing as a high quality IC socket, but only one single inline strip of them. And you're supposed to chop these up into 5-pin segments to make sockets for the LEDs, which are 5 on a side. So here are all the chopped up pin strips. And the next thing to do is to put those virtual sockets onto the pins of the LEDs. You kind of inspect them first to make sure they're all straight, and then carefully push them on. So this is what they look like after they've been pushed onto the LEDs. When you're trying to push these on, I've found that they can go on very hard and you feel like you're going to damage something or bend up the pins on the LEDs, and that's because not all the pins on the LEDs are completely lined up with the little funnels on the sockets, and if they're not really in there straight, they don't want to go in. So what I found, you can hold the LED in one hand and the socket in the other hand and just kind of wiggle it back and forth, a little twist, a little pushing and pulling that way, all the while keeping a light pressure on it. And all of a sudden you can just sort of feel them all click in there, and once you get that, then they push on fairly easily, and all 5 pins go on with little effort. But if it takes a lot of effort, something's not aligned correctly. Alright, all of the 4 LEDs now have the pin sockets on them. The LEDs are soldered to the board next, and it's important to take note of where the silk screened decimal points are, showing you which way the displays go on, because they also have a decimal point in only one corner, and it has to align with the silk screen decimal point on the circuit board. With all the LEDs temporarily pushed into the board but not soldered yet, you can see that they always want to kind of spring apart and be aligned a little oddly. Some of them have spaces, some of them don't. It's important that they all be very tight together. The instructions sort of suggest doing that by putting a piece of tape over them to pull them together, and that's a good idea. Luckily, they've given you the piece of plexiglass that will ultimately hold the display. Now in my case, I'm doing a replacement counter kit, so I already have the proper piece of plexiglass that I already set up for the useless machine. This is the piece of plexiglass that came with the replacement counter, and I haven't peeled the paper off yet, but you can stick it through here and that helps keep them in line, although not necessarily tightly together, as you can see this view shows. So while they're held in sort of an XY alignment with this, you can kind of pinch them together some more and then put some tape over them to hold them in alignment. So there's the tape holding them all together. Now it's just a matter of flipping the board over and pressing down firmly on these to make sure everything's seated, and then soldering it up. And I usually just solder anything like this that requires alignment. I'll solder one or maybe a couple of diagonal pins, recheck the alignment because it's really hard to move them afterwards if they're not aligned properly. So there are the LEDs all soldered in, and I should note that because these are sort of socketed at this point, if you did end up getting them upside down with the decimal point at the wrong corner, you could carefully pry them out of their little sockets and plug the LEDs in the other way. So it is recoverable if you do that, but it's best to get them in straight the first time. Now I'm going to take a step that's not shown in the instructions and put my red lens on this. So there's my little piece of red Lexan, which I have not glued on there yet. I'm going to wait until I've tested this before I glue it on. So the next step is to put in the PIC microcontroller, which I believe is Arduino programmed. It's a 20-pin DIP, and it does not use a socket. It just goes right onto the board and gets soldered on. Once again, it's important to make sure that the notch on the chip lines with the marked notch on the silk screen. And this chip goes on the same side of the board as the LEDs. Once again, Spikenzie is pretty careful to mark their board with the outline of the parts on the correct side of the board for where you're going to mount it. So there's the PIC chip soldered on. Then we've got this little jumper here. It has to go onto the pin here marked NC. Then it just pushes on to the pins like that. They don't say in the instructions, they don't explain it, but I'm guessing that tells the PIC processor which polarity, or not polarity, but which way the micro switch is connected, whether it breaks the contact on actuation or makes the contact on actuation. And there's no schematic provided. I haven't tried tracing the foils out either, so I'm honestly not sure which way it goes. So I'm ready to test this now. I'm going to plug in my existing useless machine's battery cable to the counter, making sure that the red lead goes on the side of the plug marked plus. And there it is working. And I can probably make it show a little better in the camera, but putting the red filter over, you can see how dramatic that is, having the filter. And etc. Now if I remove the power for a while, I think it'll just reset the count. Although once again the instructions are very poor in that area and they don't really give you much information about that. But I reconnected the power and it's, well, it cleared itself out after a few seconds. Let's see if I can make it do it again. There's the 0. And after a few seconds it blanks. I hit the limit switch once. Increments to a 1. I hope it blanks, because that was the thing that it didn't do what the other one is. Yeah, it did not blank the display. Give it a little longer here. It's not at 0, so it may take a little longer. Well, it hasn't blanked yet, but I definitely haven't shorted the pins out on this one yet like I did on the other one, so hopefully it's working the way it's supposed to. I'm going to go ahead and install it and hope for the best. Alright, so I've glued on the piece of red Lexan. Basically I put a tiny drop of super glue with a pin at this corner, and then on this side above the decimal point, and then another one in the middle. You can kind of see where it is. It makes it a little darker, but in normal application you can't see it, and especially when the LEDs are lit you won't see that, and it'll definitely improve the appearance of the display. Now this has to fit through the hole in the bezel. There we go. So that should be the end of the soldering and assembly, and it just needs to be mounted back into the case now. Now I found that the included spacer seems just a little bit too short. It's probably a standard length. And I should also point out that the reason that Spikenzie provided these SIP sockets for the LEDs was not really to have a socket, but as a way to extend them from the board a little further. And I think the main reason they did that was that they ended up with, I mean, they could have mounted the board closer to the plexiglass, but then the limit switch would have been the wrong, or the micro switch would have been the wrong distance from the cam, and I think this whole thing was an afterthought. So the whole offset here is probably due to the need to get the micro switch in the right position, and I was thinking of offsetting it back by putting these lock washers on here, just a very minimal offset, and I'm still contemplating whether to do that or not. I think it'll work alright. Worst comes to worst, I can take them back out, but that'll get the LEDs to align better with the case. Alright, so I'm ready to... So that's the improvement I got by putting the lock washers in there. The LEDs are pretty much recessed and only the plexiglass sticks out. It's just a hair of the white LED housing that extends beyond the plexiglass.
The battery pack has a red and a black wire. The motor has 2 black wires, and the cable to the counter also has a red and a black wire. And at this point, the wires from the counter cable and the battery are twisted together, the reds together and the blacks together, and then put into terminals on the machine's power circuit board, and then the 2 black leads from the motor assembly are wired into terminals on the circuit board. And to get the polarity right, the instructions say to use the terminals on the motor closest to the circuit board and furthest from the circuit board. The case assembly begins with affixing 4 posts at the corners of the case base plate or base panel, and these are just held in with screws. It's really hard to get them to go in there. They tap in very tightly. You have to hold the posts very firmly, and if a child, for example, was trying to assemble this kit, this might actually be the most difficult part. You could grab them with the pliers, but it might mar the plastic posts, so you have to do this part with a considerable amount of caution. Case assembly continues by inserting either the blank panel at one end of the case, or if you've got the display or the counter option, then the special panel that holds the counter goes in at this location. There are tabs on the edge of the plexiglass panel that insert into slots on the base panel. And then the posing plate, which says SpikenzieLabs useless machine laser engraved on there, goes in on the opposite end in the same fashion. And then finally the 2 side panels insert into the base panel. Again, there are tabs going into slots on the base. Here's with all 4 side panels, or end and side panels, inserted. They do tend to flop around a lot because nothing's really holding them except the tabs on the bottom. And at this point you have to take note of the 2 little notches in the side panels, which are where the axle on the trapdoor panel goes. You can see it's a clear piece of plastic rod that's glued onto the trapdoor panel. At this point we take note of the toggle switch on top of the power circuit board. The switch comes with various pieces of hardware and washers and brackets and so on, which all need to be removed. The top panel of the case will lay flat on the top of the switch without any extra hardware in between. Here's a picture of a lock washer and another piece of the switch hardware which would be discarded. So here's a photo of the 2 sides and 2 end panels ready for the top panel to be attached. Note that all 4 of these side panels have tabs sticking up, and those will all have to engage with slots along the edge of the top panel. And while you're putting that on, you also have to keep the trapdoor in place, and trying to get all those pieces lined up is really a trick, and I have to admit I turned the air kind of blue for a while wrestling with it. This is another area where if you have a kid, for example, doing this kit, which for the most part is, within their ability, they might need some additional supervision or assistance on this. It's not an easy step.
And it's sort of a pain to snap the top of the case on. It has to align with all these tabs and not bind the door and line up with the switch, and it's very fiddly, but it does eventually go in, and then the top 4 screws go on, and then finally the nut for the switch, which probably isn't entirely necessary, but it does help stabilize the middle of this panel, and with that big cutout there, it may need it. They say to put on this big ugly lock washer, which I can see no advantage of, and it looks butt ugly, so I just put it on there finger tight. I think that'll look better and work just as well. And now I just have to get all the fingerprints off. A little bit of Windex on a lint-free cloth. I decided to modify mine a little bit. This is the red lead, or the positive lead, going to the counter, and I have a small toggle switch here that I think I'm going to put in series with that red lead, and thereby be able to interrupt the power to the display if I don't like the way it's working, or to force it to reset without having to remove the batteries. And by the way, the batteries are on a Velcro mounted battery holder down there, so if you do need to change them, you don't have to take the whole case apart. You can just reach down there and pry that up against the Velcro, pull the battery holder out, change the batteries, and stick it back in. So for the time being, I'm not going to mount this switch anywhere. I'm just going to tuck it inside where it's out of the way. And if I turn the switch on, but I've noticed that my counter is still double counting. Sometimes it does, sometimes it doesn't. So it's activating on the, or incrementing on the up and incrementing on the down.
Okay, so I finally had to address the problem of why the display was not blanking, and also why the counter was double incrementing on each machine cycle. I was finally able to get a hold of SpikenzieLabs tech support. I never got it through their web portal. I finally had to go to customer service, and it turned out that the best way to reach them was just to put the word support at SpikenzieLabs.com, and then I got through, and after many email exchanges back and forth, which weren't really getting me to a resolution, I decided to start experimenting on my own. And I was a little confused because it seemed like the display worked better with the jumper in the NO, or normally open position, instead of the NC, or normally closed position. That was the correct one according to the assembly manual. And so I did some experiments just taking the counter out of the machine briefly so I could manipulate it easier. And with the jumper in the NC position, I found that the counter increments on the release of the snap switch's little metal arm. The counter display will then blank after approximately 3 seconds as long as the switch's arm is fully depressed. But if the arm is not fully depressed, the display will not blank. Then I tried it with the jumper in the NO position. In this case, the counter increments on pressing the snap switch's arm instead of releasing it. and the counter display will blank after 3 seconds as long as the switch's arm is not fully depressed. If you hold the arm pressed, the display will not blank. So with this in mind, then looking with the counter positioned back into the case and held in position with the case top off, I could see that the switch arm appeared to be fully pressed by the shape of the clear plastic machine arm, but the jumper was in the NC position and I could see that the display was not blanking. From my previous experiments, I knew that with the jumper in the NC position, the display would blank as long as the arm is fully depressed. This told me that even though the arm looked depressed, it was not being fully depressed. So the solution was to bend the metal arm of the snap switch slightly so that the machine's arm pushes on it a little bit more and makes sure that it is fully depressed. Once I did this, then everything was golden. The display was counting singly per each machine cycle, and also it was blanking like it should after each cycle. I confirmed this with SpikenzieLabs, and they said, yeah, sometimes you have to adjust the switch arm. They hadn't mentioned that to me before, and there's nothing about it in the manual, so I think this is a fairly important thing. I have to believe that this happens on more kits than just mine. It's such a tiny adjustment difference, and small differences in the tolerances of the assembly could result in it working properly or not working. So hopefully anybody who views this video can be forewarned and advised on how to fix this problem if they have it. A caveat to what I just said, though, is if you bend the metal arm too much, then it presses against the clear plastic machine arm excessively, and it'll make so much friction for the arm to swing from its home position to its active position that it may actually bind the arm up. So it's a really small adjustment that needs to be made, and you may have to make 2 or 3 tiny tweaks to the metal arm so that it doesn't bind the plastic arm but still is bent enough that the plastic arm fully actuates the little switch.
So how does the useless machine work? I've sketched out a electrical schematic of the circuit. You've got your 3 AAA cells, which comprise a 4.5 volt battery. You've got a normally closed limit switch or micro switch, which is held in its open position whenever the arm is fully retracted. And then you've got a DP-DT switch, which is a double pole, double throw switch. This is the toggle switch on top of the useless machine. And then finally you have the DC motor. The switch is normally at rest in this position, so the positive side of the battery can't get through the limit switch because it's being held open by the arm, so it goes nowhere. It can't get out this way because the switch at rest is in this position. So the positive side of the battery is connected to nothing, therefore the motor is de-energized and the circuit is open and the unit is at rest. When you use your fingers to move the toggle switch to the opposite position, all of a sudden the circuit dynamic changes. The arm is still at rest, therefore the micro switch is still being held open, but now the plus side of the battery has a path through the toggle switch to the motor, through the motor, back through the toggle switch, and returns to the battery. So now the plus side of the motor is this side, and this causes the motor to run in a direction that will cause the arm to move outwards, lift the trapdoor and move towards the toggle switch. Once the arm is moved away from its home position, it's no longer holding the micro switch in the open position, and it closes, but this does not change the circuit immediately because the switch is in series with an open position of the toggle switch. So the circuit remains as it was in the previous step. The motor's still positive on this side. It's still running in the direction to move the arm outwards towards the switch. When the arm finally hits the switch, it snaps it back to its normal position, which interrupts the circuit the way it was operating. Now, the plus side of the battery cannot go through the toggle switch this way. However, it can go through the closed micro switch and through the toggle switch this way, through the motor, back through the toggle switch, and return to the battery on the minus side. So therefore, this side of the motor is now positive, and that causes it to run in the opposite direction. So now the motor is immediately moving the arm back in the retraction or reversing direction. The arm continues to move in the reversing or retracting direction until it finally reaches its home position, at which time it holds open the normally closed micro switch, interrupting that circuit. So we're back to where we started with. The plus side of the battery can't go through the toggle switch or through the micro switch. Therefore, the motor is de-energized, it's off, the arm stops moving, and it's back at its initial static position. Of course, the next time you move the toggle switch to its opposite position, the whole cycle starts again. Now, the SpikenzieLabs takes this classic circuit for the useless machine and elaborates on it slightly by adding an LED circuit, which in my view is almost useless because it's hidden under the trap door and it's only on for about a half a second since the motor moves so fast, and you can barely see it. However, it's maybe a little bit cool. And without showing the rest of the circuit in operation, each side of the motor goes through a resistor and into the anode of a bicolor LED, which is really two LEDs in the same little package with their cathodes facing towards each other and connected together. And then that common cathode returns to the negative side of the motor. So when the switch circuit is in such a position that this side of the motor is positive, which is moving the arm in the outwards direction, the current not only flows through the motor, but it also flows through this resistor, through the green part of the bicolor LED, out the cathode, and returns to the battery, so it lights up green. In the retraction side of things, when this side of the motor is positive, now you have current that not only flows through the motor in that direction, but some of it also goes through this resistor, through the red half of the bicolor LED, out the common cathode, and returns to the negative side of the battery. So in this way you have not only the bidirectional motor operation, but the bicolor LED giving you a nice, albeit brief, light effect. There are a few lapses here. There don't seem to be enough instructions regarding the hardware for the switch here. If you don't unscrew all the pieces, then the top plate doesn't go down far enough, and that isn't really mentioned in the manual. They also recommend putting this lock washer on top of the case, which I think would look ugly and serves no real purpose. You're only finger tightening this. And this top nut on the switch is probably not even really needed, but it helps hold the middle part of the top panel down firmly against the switch. Otherwise it's only supported by the corners, so it's probably a good thing to have it on there, but it only needs to go finger tight. The case is really held together by the corner posts.
And as I previously mentioned, the instructions don't mention at all the potential problem with getting the counters snap switch arm adjusted properly. It's just not even touched on or hinted at, and I've already suggested to SpikenzieLabs that they add something to their manual. Since it's downloaded anyway, it's not a printed manual, and they could easily change it to avoid this issue in the future. And so I think that's a pretty significant lapse in the instructions, but I've already covered that, so I won't go on about that anymore.
But otherwise, the basic functionality of the kit is there. The switch mechanism and the motor is all pure electrical. There's no electronics involved in it, but they do tap into the motor circuit with the LEDs, so when the motor's running, you do get that green when it's coming out and red when it's going back, which you can barely see, but that's purely electromechanical circuit. There's no electronics. The only electronics on this kit is if you do get the optional counter, and it's not even tied into the main circuit. It only shares the battery, but it's its own circuit. It has its own micro switch to monitor the arm motion and thereby increment the counter. So you can operate this with or without the counter, and of course you can buy the kit with or without the counter, or you can buy the version without the counter, get the counter separately and install it and at a later date.